Me, Micki B, your host of Geo Gem Journeys and certified gemologist. So we are kicking off the Certified Gemology and Mineralogy Training Series. So I put together a clear, easy to follow presentation narrated with AI so that it will lay out the information clearly, concisely, and I think it'll do a better job than I would be able to do. So I gave it the information from my coursework, and I'm just letting AI do the presentation. So please let me know in the comments what you think. Was it good? Did you like the presentation format? What would you change? Also, quick tip, passive listening works too. When you're learning new information, I recommend if you're washing dishes, walking the dog, wherever you might be listening to something, hey, just play it and listen to it. You're going to learn a lot that way. You can always come back and watch the video later. Every module will be in a playlist with the Certified Gemology Mineralogy Training Series, so you can always come back and watch it again. So without further ado, here we go. Don't forget to let me know what you think, and as always, rock on.
Have you ever been mesmerized by a sparkling stone and just wondered, what is that really? We toss around words like crystal, mineral, and gem pretty casually, right? But it turns out, in the world of science, they mean very, very different things. So let's dive in and finally get it all straightened out. Okay, just look at this. This is a raw, completely uncut emerald, literally pulled straight from the earth. I mean, you can see that incredible green, the way it just seems to glow from the inside out. It's absolutely stunning. This is exactly what pops into our heads when we think of a precious stone, isn't it? And that brings us right to the heart of the matter. What are we actually looking at here? Is it a crystal, a mineral, a gemstone? Well, the answer might surprise you. It's actually all three. And I promise by the end of this, you're going to understand exactly why that is. So, that's our mission for this explainer. We're going to untangle these terms that get so easily jumbled up, and when we're done, you'll have a super clear framework for understanding the incredible science that's happening behind all that sparkle. All right, to really get this, we have to start at the very beginning, the foundation. And that means starting with the most fundamental term of them all, minerals. I mean, these are literally the building blocks of our planet. So what in the world is a mineral? Well, according to geologists, this is the official textbook definition. It's a naturally occurring solid substance with a definite chemical composition and a specific crystal structure. Okay, so what does that actually mean in plain English? It really boils down to 4 key rules. Think of it like a checklist. First, it has to be naturally occurring. So those lab-grown sapphires, chemically identical, sure, but not technically minerals. Second, it's got to be solid, no liquids or gases. Third, a definite chemical composition. This is like a fixed recipe. You know, quartz is always 1 part silicon and 2 parts oxygen. Always. And finally, and this is a big one, it has to have a specific crystal structure. And that last point, that's our perfect bridge to the next big idea. You know, I absolutely love this analogy from the Smithsonian. They say, if you say a rock is like a salad, each mineral would be a different ingredient of that salad. That's brilliant, right? A rock is the whole salad, and the minerals are the individual bits. The tomatoes, the lettuce, the carrots, they're all distinct things that come together to make the whole. Okay, so let's zoom in on that last part of the mineral definition, that specific crystal structure. What exactly does that mean? Well, it's the heart of our next concept. See, a crystal isn't defined by its pretty geometric shape on the outside. It's all about what's happening on the inside, at the atomic level. It's a solid where all the atoms are locked into this incredibly neat, repeating 3-dimensional pattern. We call this a crystal lattice, and it's the secret sauce. It's what gives crystals all their unique properties, from the perfect cubic shape of a salt grain to the mind-blowing hardness of a diamond. Here's a fantastic way to wrap your head around this. Think about a single, perfect snowflake. That is a single crystal. Its atoms are all lined up in one continuous, beautifully ordered pattern. Now, think about an ice cube from your freezer. That's actually polycrystalline. It's made of countless tiny, microscopic ice crystals that all got smushed together as the water froze. So, what's the opposite of a crystal? Well, if you look at quartz, the atoms are in that perfect repeating pattern, right? But in something like glass, the atoms are a total mess. They're all jumbled up with no order at all. Scientists call this an amorphous solid. And this is the fun part. It's why crystal glassware, despite the name, isn't scientifically a crystal at all. It's just glass. Okay, so let's put it all together. Every single mineral has that ordered atomic structure, which, by definition, makes them crystals. So all minerals are crystals. But, and this is key, not all crystals are minerals. Think about a sugar crystal or a snowflake. They're definitely crystals, right? But they aren't minerals because they're organic or just don't fit those other geologic rules. Okay, deep breath. We've got minerals as the building blocks and crystals as their internal blueprint. Now that we have that foundation, we can finally go back to where we started, the beautiful, sparkling things we all love to call gems. So, what makes something a gemstone? Well, this is where it gets interesting because it's not just about science anymore. It's about us. It's about the value that we humans place on it. A gemstone is chosen for its beauty, its rarity, and how durable it is. And then we transform it. We cut it and polish it so it can be worn and admired. And that transformation reveals a really important visual difference. When a mineral crystal grows out in nature, it forms these flat surfaces all on its own. Those are called faces. But when a gem cutter gets their hands on it, they cut and polish a bunch of new surfaces. And those are called facets. Their whole job is to make it sparkle like crazy. Here, take a look at this. This is a natural crystal, untouched. See those flat planes? Those are its faces. They're the outside expression of that perfectly ordered inside, formed entirely by Mother Nature. And this is what happens when you add a little human artistry into the mix. These are cut rubies. Every single one of those tiny, shiny surfaces is a facet, and each one was precisely angled by a gem cutter to catch the light and just explode with brilliance. And remember, that gemstone label is a really big tent. Some of our most beloved gems aren't even minerals. Pearls, they're organic, made by mollusks. Amber is just fossilized tree resin. And obsidian is a type of volcanic glass, which means it's amorphous. It has no crystal structure at all. But we still call them all gems. Okay, so now that we've untangled all those definitions, let's pull the camera back for the final and maybe the most surprising part of this whole story. It turns out crystals aren't just rare, precious objects you find in a museum. The International Gem Society says it perfectly. We live in a world of crystals. You don't have to dig deep into the earth to find them. And they are so right. They are all around us, and even inside us in places you would never, ever expect. Think about this. The next time you're walking on a beach, that sand crunching under your feet, it's almost entirely made of tiny eroded crystals, usually quartz, that have been broken down from giant rocks over millions and millions of years. And what about the pearl? We already said it's an organic gem, right? But that beautiful, shimmery surface it has comes from layers upon layers of microscopic crystals of a mineral called aragonites that the oyster builds up over time. But this is the most incredible part. The very things that hold you up, your bones and your teeth, get their incredible hardness and strength from tiny crystals of a mineral called hydroxyapatite. So yeah, you are quite literally part crystal. So the next time you sprinkle salt on your food, or you walk on a sandy beach, or you catch a perfect snowflake on your glove, pause for a second and ask yourself, what are you really looking at? Because you're not just seeing salt, or sand, or snow. You're seeing the beautiful, hidden, ordered world of crystals all around you, and even inside of you.